Hello everyone, welcome back to my channel. Today is day 7 of solving Geeks for Geeks problem of the day. So today's question is alien dictionary. It's an interesting question. It's been asked in many interviews. So let's see the question. So question says the given a sorted dictionary of an alien language having n words and k starting alphabets of standard dictionary. Find the order of characters in the alien language. Many orders may be possible for a particular test case, thus you may return any valid order and output will be 1 if the order of string returned by the function is correct, else 0. So the example here is the size of the dictionary array would be 5 and we need to find the order of characters having size 4 and given dictionary of words. So we need to find the order of characters from this given dictionary and return the particular string. So let's analyze this example. Coming to the explanation, here order of characters is BDAC. Note that the words are sorted and in the given language, BAA comes before ABCD. In the given language represents alien language. Here BAA and ABCD are compared and BAA comes before ABCD in alien language. Therefore, by comparing these two strings and characters of these two strings, B comes before A in the output. So in the same way, we need to compare all those strings and characters in such a way that we need to find a relation between those two characters, and finally we'll need to find the order of those characters and we need to return that in a string. So let's completely understand the given alien language from this given dictionary. So given here are the strings of the dictionary provided by the alien. So why the alien have represented BAA before ABCD and why it is placed before ABCA and it is before CAB and CAD? Let's understand. So BA is present before ABCD means we need to compare these two strings and we need to take a pointer in both the strings and we need to compare each and every character from those strings. So since every non equal characters, it shows that that particular character comes before the second character. So by comparing these two strings, we can finally say that B comes before A, and we need to create a relation between these two characters such that B comes before A and A is visited only after visiting B. So I have created a relation like B is should be come before A. In the same way, comparing these two strings ABCD and ABCA. Here, let's take two pointers and we need to compare each and every character. Since these two characters are equal, we will neglect it. In the same way, B's are equal, C's are equal, and these two are non-equal characters. So from this, we can observe that D comes before A. So we'll create a relation between these two characters such that D comes before A. In the same way, we'll compare these two strings and we'll compare each and every non equal characters. Once we'll find the non equal characters, we'll neglect all the characters comes after those two characters. So here the first two characters are non equal and in this we can say that A comes before C. So we have created a relation between A to C is A comes before C. And in the same way, the final two strings are compared. These two characters are equal, so we'll neglect it. These two characters are equal, so we'll neglect it. These two characters are not equal, so we need to create a relation. Here B comes before D, so we'll create a relation here. So as we have observed, we have generally created a directed graph here. There could be a test case like if k value is 5, but the value or the character is not present in any of the string, then we can create that character as a separate node in this whole graph. So there could be number of components in a single graph. Here you can observe that it is a directed graph as we are creating a relation a character comes before another character. So we have used directed graph, not an undirected graph. Here, directed graph plays a main role. So we have created a directed graph from the dictionary provided by the alien. Now we need to find the order of those characters, in which order those characters should be mentioned and to be returned. So since here k is values 4, we'll neglect e for now. So since we have created a directed graph, we need to find an order. Here the relation of each and every vertex is like one vertex should be visited only after a vertex before it should be visited. So this reminds of a order or an algorithm called topological sort. Topological sort is nothing but it is a linear ordering of vertices such that for every directed edge u to v, vertex u comes before in the order. As we have observed in the example, we have created this graph only for the relation between two characters which comes before another character. So in this way of creating graph, we have to use this kind of algorithm which is already built for directed graph. So topological sort, and it is only for those graph which is directed acyclic graph. It is not for undirected graph or it is not for a cyclic graph. So we need to use topological sorting in this program. So let me code the function for this, and then we'll go deep into the topological sorting algorithm. As we have discussed, we have created a directed graph from the given dictionary. So definitely we would require adjacency list. I would create the adjacency list based on size k. Then I'll iterate over the dictionary. Since we are comparing two strings at a time, we need to iterate till n minus 1. We'll take two strings. After accessing two strings from the dictionary, we'll take the minimum of both size as the size of those two strings can vary. Like for example, A, B and C, A, and another string would be C, A, B. We need to take the minimum length because the pointer can go beyond the size of another string length. So the pointer of here can be at the 4 and the pointer here ends at 3 index only. So we cannot compare the fourth with another string length which has empty characters. So we need to take the minimum length of both the string to compare. So let's take the size of both strings, and then we'll iterate. We'll take pointer variable which runs from 0 till the length, and we'll since the same characters should be neglected and we need to compare only the two unequal characters, we'll take the unequal characters of both strings. If they are not equal, we'll create an edge between these two characters. An edge can be created using adjacency list, and since these are represented in characters, we need to convert it into the integer so that we can easily calculate the sorting of those characters. So to convert this particular character into integer, we'll just subtract it with the character small a, and we'll just push it back and we'll connect it with the another character. We need to make it as an integer, so we'll subtract this also, and finally we'll break from here as we don't need any other characters after we reach a point where we find two different characters. So after this for loop, we'll create an adjacency list, something like this. And from here we need to find the order. Order can be more than one, since topological sort does not only gives one particular way of order. It can vary more than one. We'll look after this after a minute. So from here we need to create a function topological sort, and we need to pass the size and the adjacency list to it. This function toposort will give us a order from the given directed graph, and will store that order into a vector. Now this vector topo will have the order of the graph, and now we need to convert that values which are present in integer, we need to convert that into a string. So we'll just take a variable string answer, and we'll iterate over the vector topo, and since it is in the form of integer, we'll just convert it in the form of string. So we'll add character a to it. After converting all those characters into a string by converting integers into a characters and then characters into the string, will return the final answer. So for now we need to create this function toposort. Before creating this toposort function, let me explain more in detail about topological sort and the way it works, and then we can write the code for this. So as I said, topological sorting is for direct acyclic graph, and it is for a directed edge U to V, where vertex U comes before V in the ordering, and it can be done in a different way using DFS and both BFS. So let's go for DFS for now. So we can create the ordering of the graph by using stack. As we are pushing elements into the stack, it will maintain an order like for an element 5 pushed into the stack, and the next elements which are pushed into the stack will be visited only after the element 5. So the stack helps us to maintain that track where a vertex is visited only after the particular vertex which comes before it is visited. So we'll create an adjacency list for the direct acyclic graph, and then we'll use the help of stack to maintain the vertices into and push it into the stack to maintain the track. And finally, after visiting each and every vertex of the graph, we'll pop all those elements from the stack and will store those values into a vector. That particular vector will represent the topological sort values of that particular graph. So in this way we can find the topological sort or values of a direct acyclic graph. So the code for this would be something like this. We'll create a function vector of int toposort. We'll take number of vertices and the adjacency list. So the code of the topological sort would be in this way. Initially we'll take a vector of bool which takes a number of vertices and initially marked as false. We'll take a vector of answer which stores the order of the topological sort, and we'll take the stack to track the order of elements pushing into it. We'll iterate over the vertices. If that particular vertex is not visited, we'll call DFS function by sending that particular vertex adjacency list, visited vector, and the stack value. And finally, after the stack gets filled, we'll just pop all those elements present in the stack and store it in our answer vector. We'll take the topmost element of the stack and we'll pop the pop that value from the stack, and finally we'll return that answer. So let's write the function for the DFS function. It takes node value, it takes adjacency list, it takes visited array, and it takes stack. We are sending stack as a reference value, as we need to store that we need to use that stack in our function. So initially we'll mark that particular node as true, and we'll go through its neighbors using adjacency list, and if those neighbors are not visited, we'll again call this function to get visited. And finally, after each and every nodes of the graphs are visited, we'll push all those elements into the stack. So from this function, the stack gets filled by all those nodes in our required order. And after this stack gets filled, since we are passing this stack as a reference value, we can use that stack here, and it will automatically stored in topo stack here, and we can use those values and push it all in our required answer vector, and finally we can return that vector. So let's compile and run. As you can see, our problem got submitted successfully. So hope you like this video and explanation. If you have any more doubts, you can refer this link, which clearly explains about topological sorting. They have given an excellent explanation on this, and for more thing you can Google it. So this is all about this question and this video. If you have liked it, please give a like and subscribe to my channel. I'll see you in the next one. Thank you.